So whereas an ideal reconstruction filter, GA of omega, is really called the reconstruction filter for this converter. The zero order hold reconstruction filter is the sinc function. So I'll get a little bit of distortion of the waveform in the range minus pi over t to pi over t due to the curvature of this sinc function. So instead of getting this nice reconstruction, I may end up with something that's actually more warped, where the higher frequencies are suppressed. And then outside the range minus pi over t to pi over t, where in an ideal D to A converter there will be no energy, I'm actually going to get this energy mapped in. So I'm going to get some components that sit there. Here's minus 2 pi over t. Here's 2 pi over t. And these components will be in there. And I'll get some more energy over here. And in fact, this sinc goes on forever. So I'm going to get some energy every 2 pi over capital T. So there'll be a lot of extra image energy sitting outside here. So if you use a zero order hold converter, you can imagine that you probably want to clean up the output of that converter with something that has a magnitude response that maybe emphasizes high frequencies and then gets rid of and rejects all the images. This you might do in discrete time. Maybe you do some discrete time pre-emphasis. So you might first pre-filter the signal Y with a discrete time filter to emphasize these frequencies so that the shape here is better. This part you can't do in discrete time. So this you might use a better analog filter on the output. After you've gone through your D to A converter, you might use a better analog filter in the output. Or your zero order hold converter, you might use after your zero order hold, you might use a better analog filter to reject these samples over here, or these aliased, not aliased, these image components over here. We'll talk later in the course about ways that you can do this using an oversampling converter to relax the specifications on the analog converter. Okay, so now let's put all those things together. And recall that if I have x of n going through an ideal D to C converter with rate capital T, then in that case my GA of T would be a sinc function, and I'd get perfect rejection of the out-of-band images, and I'd get a gain of capital T to cancel out the gain of 1 over T, and I'd perfectly reconstruct the original signal so that YA of omega, let's call this Y of T instead, YA of omega gives me Y sub D of omega T in the range magnitude of omega less than pi over T, and it's 0 otherwise. So putting it all together, if I start with an analog signal, I sample it with an ideal C to D converter, and then I reconstruct it with an ideal D to C converter, then first I won't require that this be band limited. Let's figure out what the output would be. We know that if I do this sampling, this part will give me, let me call this discrete time signal Y of n, will give me discrete time signal Y of n whose DTFT, Y sub D of omega, is 1 over T times the sum of x of A of omega plus 2 pi k over capital T. That's my DTFT. And we know that Y sub A of omega is 1 over T G sub A of omega times Y sub D of capital omega capital T. So I need to plug in this expression with little omega equal capital omega capital T. So this will be times the sum of So this gives me 1 over t times g sub a of omega times the sum of x sub a of omega plus 2 pi k over capital T. So what does this say? This says I've got a scaled by 1 over t version of a periodically aliased spectrum, then I multiply by GA of omega. Now if GA of omega is equal to, if GA of omega is equal to t for the magnitude of omega less than or equal to pi over t, and 0 otherwise, and if xa of omega were band limited to pi over t, then the output ya of omega would equal xa of omega. So in order to get this, I need the original signal to be band limited to pi over t, so that this spectral replication every 2 pi over capital T doesn't give rise to detrimental aliasing. That's where the band limiting is required. If xa of omega is band limited, then these don't alias. Then I need GA of omega to be a brick wall filter. In other words, GA of t has to be a sink, and I'll get exactly perfectly reconstructed outputs. Okay, why don't we stop there, and I will see you in class on Thursday.